Hi friends, welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the UPSC Civil Service main examination of the previous year questions of the signal and systems in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel. And don't forget to press the bell icon button. So whenever you upload a new video, the direct notifications comes to mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the 16th question. See the question here. Determine the inverse Laplace transform of the h of s is equal to ln of 1 by s plus 4. So here they are given a h of s. It is ln of 1 by s plus 4 and we need to figure out what is the Laplace inverse, means the time domain expression we need to figure out. And this question is given in the IAS 2006 for 5 marks. So let's solve this numerical. In the question they are given the h of s is ln of 1 by s plus 4. ln means it is the log base a. So now we need to find what is the Laplace inverse, means time domain expression, means h of t expression we need to figure out. So therefore here what I am going to do is, now I am going to do here 1 by s plus 4, I am going to take it the upwards. So therefore s plus 4 all to the power of minus 1, because 1 by is equal to e to the power of minus 1. So in that fashion I am going to write, as it is a minus 1, it is going to come to the here. So therefore minus ln of s plus 4. So therefore we can write in another fashion. So now what I am going to do is, now I am going to the differentiation of this one. So therefore dh of s by ds is equal to, this is will become now minus 1 by s plus 4, because here differentiation of the log base x e, it is nothing but 1 by x. So therefore differentiation of this log of x base e. So here also same thing here. So log of x is nothing but 1 by x. Here there is a minus, and if you do the inside again differentiation, s will become 1 and the 4 will become 0. So 1 plus 0 is nothing but 1. So into 1. So this is the thing we are going to get. So now what we are going to do is nothing but, we have to know some basic formulas in order to solve this numerical. So the basic formulas are, if x of t which has a Laplace transform of x of s, if x of t has Laplace transform x of s, then t to the power of n x of t is going to have Laplace transform. This is a very fundamental formula, which is minus 1 over to the power of n d to the power of n x of s by ds to the power of n, means here minus 1 over to the power of n, and you have to do the n times the differentiation of the previous one in order to get an expression which is t to the power of n x of t. So now I am going to assume n is equal to 1. Let's see what is happening if you assume n is equal to 1, which is t into x of t, which is going to give a Laplace transform of minus 1 over to the power of 1 is again minus 1, and similarly in place of n you have to place here 1. So therefore it is nothing but first differentiation. So d of x of s by d of s. So therefore finally what I am trying to say is nothing but, here suppose now I am going to multiply this both sides by minus 1. So therefore this will become minus t. Here minus 2 minus will become plus, means I am going to take this minus to this equation. So therefore here this, so for minus t into x of t, the Laplace transform is nothing but d of x of s by ds. So now what I am going to do is nothing but, here in place of x I am going to take it at h, because I am going to replace x of t by h of t, and see the equation. Same thing, minus t into h of t has a Laplace transform dh of s by d of s for our convenience. So therefore minus t into h of t will have a Laplace transform which is dh of s by ds, but we know the expression of the dh of s by ds, which is minus 1 by s plus 4. So therefore dh of s by ds is equal to minus 1 by s plus 4. So therefore here the Laplace inverse of this, expression is nothing but minus t into h of t. So therefore minus 1 by s plus 4, the Laplace inverse is minus e to the power of minus 4t u of t, because here for e to the power of minus 80 into u of t, the Laplace transform equation is 1 by s plus a. So if you compare those equations, so therefore we are going to get, as there is a minus, you have to keep here minus, but we need only h of t, so therefore h of t is equal to this minus get cancels, and then t is, I am going to take it to the denominator. So therefore e to the power of minus 40 by t into u of t. So therefore this is the actual Laplace transform of this equation. So for this h of s, the Laplace inverse is h of t. So therefore if you do this Laplace transform, this you are going to get. So finally what I am trying to say is nothing but, see, if h of t is equal to e to the power of minus 4t by t into u of t. So if you do the Laplace transform of this one, we are going to get h of s, which is nothing but here ln of 1 by s plus 4. So in the question they are given the h of s and they are going to ask the Laplace inverse. So by these equations, by these fundamental equations, we rearranged and then we got this expression, which is h of t is equal to e to the power of minus 40 by t into u of t. So therefore this is the correct solution of this question. So now we are going to solve the 17th question. This is the question here. So determine the Laplace transform of the function f of t shown below. So in this question they have given a function f of t and we have to find what is the Laplace transform of this function f of t. So here this question is given in the IAS 2009 for 5 marks in the mains examination. So let's solve this numerical. So this is the question here. They are given a f of t function with respect to time. They have given the graph. So therefore it is a triangle graph. From 0 to 2 it is going to have maximum peak value at time instant 1. It is going to have maximum peak value 2, and remaining all other instants this function is going to have a 0 value. So now we need to find what is the Laplace transform of this function f of t. So this question can be solved in 2 methods. So now I am going to tell you about the first method. So here this first method is very easy rather than the second method. So here for f of t the Laplace transform is f of s. So now I am going to assume a signal which is g of t. G of t is nothing but here differentiation of the original signal. So d by dt of the f of t. So for g of t the Laplace transform will be g of s, but df of t by dt the Laplace transform will be s into f of s. So therefore g of s is equal to s into f of s. So what I am going to do is nothing but I am going to construct another signal g of t. So with the help of g of t now I am going to find what is the g of s. And then I am going to equate the g of s is equal to s into f of s. Then I can figure out the f of s. That is the concept here. So therefore now I am going to take a signal g of t. So g of t is nothing but differentiation of the previous signal, means original signal. So this is a straight line. In 0 to 1 it is nothing but a straight line. And here the slope is nothing but here this 2 by 1 it is nothing but 2. So therefore the slope is nothing but here 2. So therefore for any straight line, if you do the differentiation it is a horizontal, so therefore it is a constant signal because its slope is constant. So therefore the slope is plus 2. And similarly from here this is a straight line with a down slope, so therefore the slope is nothing but here minus 2. Here the slope is here, this is height is 2 and here is 1, so therefore 2 by 1 is nothing but 2. This is the slope here, and similarly this is a slope 2. For here this is the nothing but here this line is a going down, so therefore here this is nothing but height is 2, the length is here 1, but it is a decreasing, so therefore minus 2 is the slope. And this line has a slope of plus 2 and this line has a slope of minus 2, so therefore here also minus 2. So from 0 to 1 this function is going to have a value of plus 2, and from 1 to 2 this function is going to have a value of minus 2, and remaining all other instants this g of t is going to have a value 0. So that is what I have written. So g of t is equal to for 0 less than or equal to t less than or equal to 1, and minus 2 for 1 less than or equal to t less than or equal to 2, and it is 0 otherwise. So with the help of this graph g of t I am going to find the g of s. Therefore g of s is equal to integration t is equal to minus infinity to plus infinity g of t e to the power of minus st into dt. So now I am going to redefine these limits because g of t is existing only from 0 to 2 and remaining all other instances 0, but from 0 to 1 it is going to have one value, and from 1 to 2 it is going to have another value. So therefore here from 0 to 1 it is going to have a value of 2. So therefore from t is equal to 0 to 1 this g of t is going to have a value of 2, and remaining thing is same, e to the power of minus st into dt, plus because from 1 to 2 this function is going to have minus 2. So therefore from 1 to 2 this function is going to have minus 2 e to the power of minus st into dt, and remaining all other instances is 0, means for remaining other integration domain it is 0. So therefore now we have to do the integration here. 2 is a constant, I am going to take outside, and integration of e to the power of minus st is nothing but e to the power of minus st by minus s, and we have to substitute the limits t is equal to 0 to t is equal to 1. And similarly this minus 2 is going to come outside because it is a scalar part, and now we have to do the integration of this e to the power of minus st, which is e to the power of minus st by minus s, and we have to substitute the limits t is equal to 1 to t is equal to 2. So t is equal to 1 to t is equal to 2. So therefore upper limit minus lower limit I am going to substitute here, as s is a constant, so therefore this minus s is going to come outside, which is minus 2 by s. So now I am going to substitute the upper limit minus lower limit, so e to the power of minus s minus 1, and similarly this minus 2 by minus s is nothing but plus 2 by s. Again now I am going to substitute the upper limit minus lower limit, so which is e to the power of minus 2s by e to the power of minus s. So if you rearrange properly then we are going to get g of s is equal to minus 4 by s e to the power of minus s plus 2 by s plus 2 by s into e to the power of minus 2s, but we already know g of s is nothing but s into f of s. So g of s is equal to s into f of s. Same expression I have written here, but I want f of s, so therefore I have to divide this s by this side. So therefore I am going to get minus 4 by s square e to the power of minus s plus 2 by s square plus 2 by s square into e to the power of minus 2s. So now after rearranging this one, finally we are going to get f of s is equal to 2 by s square into 1 minus 2 into e to the power of minus s plus e to the power of minus 2s. So let me write here f of s. So after rearranging, finally we are going to get 2 by s square into 1 minus 2 e to the power of minus s plus e to the power of minus 2s. So therefore this is the final expression of this one. So therefore for this graph with a slope of plus 2 and minus 2 and remaining all other 0, the function f of s is the Laplace transform f of s is equal to 2 by s square into 1 minus 2 into e to the power of minus s plus e to the power of minus 2s. So now we will solve in the another method. So this is the method 2. So what I am going to do is now I am going to find the function f of t. So here from 0 to 1, this line, this is the straight line equation is which is 2t. So for 0 less than or equal to t less than or equal to 1, this is the equation. And similarly from 1 to 2, we have to find what is the expression of this function f of t, which is minus 2t plus 4. So for 1 less than or equal to t less than or equal to 2, meaning all other instead it is 0. So here now I want to find what is the Laplace transform of this function f of t. So for f of t, the Laplace transform is f of s is equal to integration t is equal to minus to plus infinity f of t e to the power of minus st into dt. But this function is defined only from 0 to 2 and remaining all other instance it is 0. From 0 to 1 it is going to have equation 2t, from 1 to 2 it is going to have equation minus 2t plus 4. So therefore now f of s is equal to integration t is equal to 0 to 1. So f of t is nothing but in 0 to 1 it is 2t, and similarly from t is equal to 1 to 2 this function f of t is going to have equation minus 2t plus 4. So now we have to do the integration of this part and this part, and then we have to substitute the limits, and then finally we have to rearrange. So here 2 is a constant, it is going to come outside. So therefore integration of t into e to the power of minus st, it is nothing but integration of f into g. So integration of f into g, it is nothing but f into integration of g minus f dash of double integration of g and plus f double dash of triple integration of g, and we have to move on. So therefore this is the thing I have already told you. Here we have to follow the rule ILET. ILET is nothing but here inverse functions, logarithmic functions, algebraic functions, t means trigonometric functions, and d means exponential. So whatever the thing, the first priority has to give to the function f, and the remaining thing you have to give for the g. And t is nothing but an algebraic equation, and e to the power of minus st is nothing but an exponential function. So you are going to come, the first thing is you are going to get the algebraic, and then you are going to get the exponential. So whatever the first you are going to get, that we have to assume as f, and the remaining thing is as e. So therefore here f is going to be algebraic, means here f has to be equal to 2 and g has to be equal to the exponential, which is e to the power of minus st. So by using this formula, now what I am going to do is, now I am going to do the integration of this one. So finally I am going to get this expression with the limits t is equal to 0 to t is equal to 1, and the same principle here. So here also same, this is algebraic and this is exponential. So therefore the first thing is, so f has to be algebraic and g has to be exponential. So by this principle, ILET principle. So therefore now what I am going to do, same formula I am going to substitute, use, and then we are going to get the, this is the expression. So same thing, we have to substitute the limits, and t is equal to 1 to t is equal to 2. So finally after substituting the limits, this is the expression I am going to get. So this is for the first thing and this is for the second thing after substituting the limits. And if you do the proper rearrangement, finally you are going to get f of s is equal to 2 by s square into 1 minus 2 into e to the power of minus s plus e to the power of minus 2s. Here the simplification is very higher when compared to the previous thing, because we have, this is a very complicated signal, but for the previous one we have converted into a very simple signal, and then we did the integration in a very easy manner. But here we are doing the, because we are not going to convert into any other form, any other signal, but we are going to use a direct expression of this function f of t in that particular domain in the time period, and then we have solved this one. That is the reason here the simplification is higher, but still we are going to get the same result as the previous one. So now we are going to solve the 18th question. See the question here. Impulse response of two systems are given as h1 of n is equal to delta of n and h2 of n is equal to u of n minus 1. Determine which of the above systems are the causal and memoryless. So they are given two systems with the impulse response in the discrete time domain, and we have to check the two properties, which are the causal properties and also memoryless. So we have to tell which system is a causal, memoryless, and similarly for the second system also we have to go for these properties. And this question is given in the IAS 2006 for 5 marks. So let's solve this numerical. So here this time they are given, the first thing is h1 of n is equal to delta of n. So we have to check the two properties, the causality property and also the memoryless, whether the system is memoryless or not, also we have to figure out. So here what I am going to do is, first I am going to define what is the causality and also the memoryless. So here for causality, the definition is nothing but here a system is said to be causal only when if the output is independent of the future inputs. So if any system which is independent of the future inputs, then we can say that system is said to be a causal system. Means if for any system if the output is independent of the future input values, then the system is said to be a causal system. So in the impulse response domain, we can define like this. See, whenever the impulse response is equal to 0 for n less than 0, this is for the discrete time, and for the continuous time it has to be h of t is equal to 0 for n less than 0. If this condition is satisfied, then we can say that system is said to be a causal system. This is said to be a causal system. And similarly here for the memoryless system, so for memoryless system, here the impulse response h of n has to be equal to delta of n, and here in the time domain, which is h of t is equal to delta of t, then only we can say this system is said to be, then only we can say this LTI system is said to be a memoryless system. So this is the condition for the causality, and this is the condition for the memoryless. Means for causal system, the output has to be independent of the future input values. Only the system is said to be a causal system. If you want to define in terms of the impulse response, so h of n is equal to 0 for n less than 0 in the discrete time, and h of t is equal to 0 for t less than 0 in the continuous time. And similarly for the memoryless system, is output is not going to depend upon the past values of the input, or either it can be future values of the input. Then only we can say that system is said to be memoryless. Means it is not going to store any past or future values of the input. Then that system is said to be a memoryless system. Means it is going to depend upon only on the present instant value of the input. So but if you want to define the memoryless in terms of the impulse response, then h of n is equal to delta of n, and h of t is equal to delta of t. Suppose this impulse response in the discrete time, it has to be equal to delta of n, and in the continuous time it has to be equal to delta of t. If any h of n which is not in this fashion, then we can say blindly that system is said to be it is not a memoryless system. So here in this question they have given h1 of n is nothing but delta of n. So now we have to define this one. So directly you must not write, you have to explain some of the important things, and then we have to write, because it's a conventional paper. So here for this system, if the input is x of n and the output is y of n, for this first system the impulse response h1 of n is equal to delta of n. So therefore y of n for any LTI system is nothing but input convolution of the impulse response. Input is x of n and the impulse response is h1 of n. So we are going to the convolution. So therefore x of n in convolution of here h1 of n is nothing but delta of n. So if you take any signal and if you do the convolution with respect to delta of n, same signal we are going to get. So therefore x of n. So therefore y of n is equal to x of n. See, means whatever the input, the same thing we are going to get as the output. This type of system is said to be identity system. When the output is equal to present input, then we can say this system is said to be an identity system. And if you see carefully, the output is going to depend upon only on the present value of the input. It is not going to depend either on past or either future values. So we can say this system is said to be a memoryless. Yes, this system is a memoryless. And also here h1 of n, we know h1 of n is nothing but delta of n. So therefore h1 of n is defined only at delta is equal to, means at n is equal to 0, and remaining all other instances it is not going to define. So therefore we can say this h1 of n is equal to 0 for this h1 of n is equal to 0 for n less than 0. So therefore we can say this system is said to be a causal system, and it is also this h of n is equal to delta of n. As I have already told you, whenever the impulse response is delta of n, this system is said to be memoryless. But you have to explain in this manner, because you have to write in a big manner, because it's a conventional paper. So finally what I am trying to say is nothing but it is a causal system and it is also a memoryless system. Now let's go for the second thing. Here the impulse response h2 of n is equal to u of n minus 1. So now we have to check the two properties here also, causal property and also the memoryless property. See here also same thing here, same thing. Suppose this is the h2 of n and this is the input x of n and this is the impulse response, and now I want to find what is the output. Same thing, output is equal to input convolution of the impulse response. So now I am going to use the commutative property. By commutative property we can interchange this one. So therefore H2 of n convolution of x of n, by using the basic convolution property, which is sigma k is equal to minus into plus of H2 of k in place of n substitute k and in place of n substitute n minus k. So now H2 of n we know u of n minus k, u of n minus 1, and I have to know H2 of k means in place of n substitute k, which is u of k minus 1, and similarly x of n in place of x n substitute n minus k, which is x of n minus k. See this u of k minus 1, so u of k minus 1 is nothing but you have to draw with respect to k. This is going to define, so u of k minus 1 is going to define only from k is equal to 1. So from k is equal to 1, this value is going to have value 1. Means from k is equal to 1 to infinity, this function is going to have a value 1, and remaining all other instance it is 0. So therefore the integration is the summation is going to converge from k is equal to 1 to infinity, because remaining other instance for k less than 1 its value is 0. So therefore we have to do the summation from k is equal to 1 to infinity. So therefore this value will become 1. So 1 into anything is x of n minus k. So if you see carefully here, now I am going to substitute this value k is equal to 1, k is equal to 2, k is equal to 3 up to infinity. So therefore x of n minus 1 plus f x of n minus 2 up to so much things. So if you see carefully one thing here, this output is going to depend upon the past values of the input. So we can say this system is said to be it is not a memoryless, means it is going to have some memory. So therefore the system is not a memoryless system, means this system is going to have some memory. And also here h2 of n is equal to 0 for n less than 0. Yes, because this function is defined. So therefore for n is equal to from 1 to infinity only this function u of h of n is defined, h2 of n is defined. So its value is 1. But at n less than 0 its value is 0. So we can conclude that this system is said to be a causal system. So finally this system is it is not a memoryless system and it is a causal system. So blindly or based on these properties also you can define instantaneously, but it is a conventional paper, means you have to write in this manner, then only you are going to get the marks. So now we are going to solve the 19th question. See the question here, using z transforms obtain the convolution sum of two sequences. So here y of n is equal to x1 of n convolution of x2 of n. So they have given a x1 of n sequence and also x2 of n, which is u of n minus u of n minus 3. So where u of n is a unit step sequence. So in this question they are given a x1 of n signal and also they are given a x2 of n. So now we need to find, you have to do the convolution of x1 of n and x2 of n in a z transform method by using z transform. So they also given, you have to solve this question in terms of the z transform. So this question is given in the IS 2009 for 10 marks. So we have to do the convolution in the terms of z transform, and this question is given in the IS 2009 for 10 marks. So let's solve this numerical. So in the question they are given a x1 of n, it is a signal they are given, which is 1, 2, minus 1, 0, 3, means at remaining all other instant the signal is 0, and this arrow indicates that the signal is going different from n is equal to 0. So at n is equal to 0 the signal has a value of 1, and n is equal to 1, 2, at n is equal to 2 it is minus 1, and n is equal to 3 it is 0, and n is equal to 4 its value is 3, and remaining all other instance its value is 0. And similarly x2 of n, which is u of n minus u of n minus 3. So if you do the graph and if you do this one, see u of n is nothing but it is going to define from n is equal to 0. So from n is equal to 0 it is going to define. So 0, n is 0, 1, 2, 3, and it is going to define. And similarly u of n minus 3, it is means it is going to define from 3 value. So it is infinity. So if you see, if you do the subtraction, so that from 3 this both all going to get cancelled, but from 0, 1, 2, this is 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 0 is nothing but 1, means it is going to define only 0, 1, 2, and remaining all other instance its signal is 0, which is here u of n, and this is u of n minus 3. So if you do the subtraction, we are going to get 1, 1, 1, means it is going to define at only n is equal to 0, n is equal to 1, and n is equal to 2, and remaining all other instance its values 0. So this is n is equal to 0, 1, 2. So that's what I have written here. So it is nothing but 1, 1, 1, means we are going to keep an arrow, means this indicates the signal is going to present from n is equal to 0, its value is 1, at n is equal to 1 its value is 1, and n is equal to 2 its value is 1. So now I want to do this convolution x1 of n into convolution of x2 of n in the z transform. By using z transform, we have to simplify and we have to figure out what is the y of n. So in the z transform, if you do the discrete time system, the convolution in the discrete time system will become multiplication in the z transform. So therefore, if you do the z transform, y of n is y of z, and x1 of n is x1 of z, and x2 of n is x2 of z. So the convolution in the time domain will become multiplication in the z transform. So this convolution is converted to multiplication. So multiplication. So finally, what is the z transform for x of n? The basic formula is x of z is equal to sigma n is equal to minus n to plus n of x of n into z to the power of minus n. Z to the power of minus n. So therefore, this is the basic formula. By using this formula, we have to convert the x1 of n into x1 of z, and similarly x2 of n into x2 of z. So therefore, x1 of z is equal to sigma n is equal to minus n to plus n of x1 of n into z to the power of minus n. But this x1 of n is defined from only n is equal to 0, 1, 2, 3, 4. So from 0 to 4 only this signal is defined, and remaining all other instant it is 0. So therefore, sigma n is equal to 0 to 4, x1 of n into z to the power of minus n. So you have to take here n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. This is the thing we are going to get. And we know the value of x1 of 0, which is 1, and x1 of 1 is nothing but 2, and x1 of 2 is nothing but minus 1, and x1 of 3 is nothing but 0, so 0, and x1 of 4 is 3. So after substituting those values, we are going to get this expression, which is x1 of z. And now we have to do the same process to figure out the x2 of z also. Similarly, x2 of z is equal to sigma n is equal to minus n to plus n of x2 of n into z to the power of minus n. But here the signal is different from 0, 1, 2. So from 0 to 2 only the signal is different, and remaining all other instants its value is 0. So therefore, n is equal to 0 to 2, x2 of n into z to the power of minus n. So substitute here, n is equal to 0, n is equal to 1, and n is equal to 2. So we know the value of x2 of 0, which is 1, and x1 of 1 is 1, and x2 of 2 is nothing but 1. So this is the thing we are going to get. So we figure out the x1 of z and also x2 of z, and we have to do the multiplication, because y of z is equal to x1 of z into x2 of z, and do the multiplication of this x1 of z and x2 of z. If you do the multiplication, and finally we are going to get this expression, which is 1 plus 3 into z to the power of minus 1 plus 2 into z to the power of minus 2 plus z to the power of minus 3 plus 2 into z to the power of minus 4 plus 3 into z to the power of minus 5 plus 3 into z to the power of minus 6. This is the thing we are going to get finally. So here now we have to compare with the standard equation. We all know y of z is equal to sigma n is equal to minus 2 plus 2 y of n z to the power of minus n. And if you compare these two equations, we are going to get y of n is nothing but 1, 3, 2, 1, 2, 3, 3. So this is the sequence of this signal. Only from n is equal to 0, 1, 2, 3, 4, 5, 6. From 0 to 6 only the signal is defined, and remaining all other instant its value is equal to 0. So this is the sequence. So you have to do this convolution in terms of the z transform method, and you have to do in a step-by-step manner. And if you want to check whether your solution is correct or not, simple method is, so here for x1 of n, the number of samples here 1, 2, 3, 4, 5. So there are 5 samples here. So there are total 5 samples here in the x1 of n. And similarly, the number of samples in the x2 of n is 1, 2, 3. So there are total 3 samples. So in order to find what is the number of samples in the y of n, the basic formula is nothing but, here you have to add these two things, 5 plus 3, and you have to separate minus 1, which is 5 plus 3 minus 1 is nothing but, so this y of n is going to contain the 7 samples. So you can see here 1, 2, 3, 4, 5, 6, 7. Yes, this signal y of n is contained the 7 samples. So the basic formula is nothing but, here suppose this x1 of n is going to have some n1 samples, and this x2 of n is going to have samples n2. So therefore the number of samples in the y of n is nothing but n1 plus n2 minus 1. So these many number of samples are going to present in the y of n. So by using this formula also we can check whether the number of samples in the result is equal to the thing which we got by the formula or not. So that is also a very tricky method. So these are some of the important things here. So you have to convert this x1 of n into x1 of z, and this x2 of n into x2 of z, and you have to multiply these two things by the basic fundamental equation, and then you have to rearrange this, and then you have to compare with the standard equation. Then we are going to get the sequence of y of n. This is the solution of this question. So now we are going to solve the last question of this lecture. See the question here. Find the Laplace transform of the following function f of t is equal to t into cos omega t. So for this f of t is called t into cos omega t, we need to find what is the Laplace transform f of t. For f of t, we have to find what is f of s. And given Laplace transform of sin omega t is equal to omega by s square plus omega square. So the Laplace transform of sin omega t into u of t is nothing but here omega by s square plus omega square. And using the result of the previous one, we have to find what is the Laplace inverse of the 1 by s square plus omega square. So here we also have to find what is the Laplace inverse of the 1 by s square plus omega square also we need to figure out by using the above result. So this question is given in the IAS 2003 for 10 marks. So let's solve this question. So in this question they are given an expression f of t is equal to t into cos omega t. So we have to find what is the Laplace transform equation f of s, and also we have to find what is the Laplace inverse of the 1 by s square plus omega square also we have to figure out. They also given that Laplace transform of sin omega t is omega by s square plus omega square. So by using this formula we have to find what is this f of s and also the time domain expression for this one, means Laplace inverse of this function. So these two things we need to figure out. So before I solve this numerical, let me tell you small formulas here. Suppose if f of t is going to have a Laplace transform x of s, then dx of t by dt is going to have, which is s into x of s. So for the first derivative we are going to get s into x to the power of s. And similarly the another formula is t to the power of n x of t is going to have the Laplace transform which is minus 1 over to the power of n d to the power of n x of s by ds to the power of n. So this is the three formulas. By using these formulas we are going to solve this numerical. See carefully here, for sin omega t, the Laplace transform is omega by s square plus omega square. So now what I am going to do is, now I am going to do the differentiation of the previous one. Means the differentiation of the sin omega t is omega into cos omega t. So if you are going to go for the differentiation, then the Laplace transform will be s into previous Laplace transform x of s. So s into the previous value Laplace transform is omega by s square plus omega square. S into previous value Laplace transform, which is omega by s square plus omega square, which is nothing but s omega by s square plus omega square. So if you see carefully, here omega is there, here omega is there. So omega get cancels. So therefore cos omega t is going to have a Laplace transform s by s square plus omega square. So therefore cos omega t will have Laplace transform s by s square plus omega square. So now what I am going to do is, see carefully, if x of t has a Laplace transform x of s, then t to the power of n x of t will have a minus 1 rolled to the power of n d to the power of n x of s by ds to the power of n. Here there is only t to the power of 1, only 1 is there. So therefore here you have to substitute n is equal to 1. So therefore for n is equal to 1, this will become, so for t x of t, the Laplace transform will become minus f dx of s by ds. So this is the formula. So for t into x of t, here the Laplace transform will be minus into d of x of s by ds. So therefore here, now for this signal I am going to multiply t. So I am going to multiply t. So therefore what is going to happen? Minus 1 d by ds of previous value, which is previous Laplace transform, minus into d by ds of previous value, which is s by s square plus omega square. So u by v differentiation, so u by v is nothing but u by v. If you want to do differentiation, u derivative v minus uv derivative by v square. So by using this formula, u is nothing but s and v is s square plus omega square. So u dot is nothing but here 1 into s square plus omega square minus here s into, now you have to do the differentiation of this one, it will become 2s. So if you solve this one, if you rearrange this one, finally we are going to get s square minus omega square by s square plus omega square whole square. So I have written here. So therefore this t into cos omega t is going to have a Laplace transform, which is s square minus omega square by s square plus omega square whole square. So therefore t into cos omega t is going to have a Laplace transform, which is s square minus omega square by s square plus omega square whole square. So therefore we figured out the expression f of s. So therefore f of s is equal to s square minus omega square by s square plus omega square whole square. So this is what we have figured out. Now we also find what is the Laplace inverse of this one. So we basically know sin omega t is omega by s square plus omega square. So now what I am going to do, I am going to multiply these two equations by omega. So therefore sin omega t by omega, so omega get cancels, we are going to get 1 by s square plus omega square. So therefore the Laplace inverse of this square plus omega square is nothing but sin omega t by omega. So therefore here this is a thing. So finally the Laplace inverse of 1 by s square plus omega square is nothing but sin omega t by omega. So finally we have figured out the f of t expression, means for f of t function we have figured out what is the Laplace transform f of s, and also for this Laplace inverse of 1 by s square plus omega square, it is nothing but sin omega t by omega. It blindly simplifies nothing but here for sin omega t by omega, if you do the Laplace transform, we are going to get 1 by s square plus omega square, or simply we can tell the Laplace inverse of 1 by s square plus omega square is nothing but sin omega t by omega. So therefore this is the correct solution of this question. So by this lecture we have successfully completed the 20 questions which are the previous year UPSC Civil Service main examinations of the signal and systems in a very very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload a new video, the direct notifications comes on mobile. If any improvements needed in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.